Good morning, everyone. Welcome to the next chapter in our Minoxidant webinar series. My name is Brian Phipps. I'm one of the engineers here at Minoxidant. I'm joined today by Fiberglass Division Manager Jim Wishusen. Jim's been with Minoxidant since 2010, and as the division manager, provides frontline support for both the representatives and end users and also installers of our fiberglass products. A little bit of housekeeping before we get started. In the lower left corner of your screen, you'll note that there's a chat box that you can type in any questions or comments that may come to mind as we go through the presentation, and we'll do our best to answer them as we go throughout the presentation. Without further ado, I'll go ahead and turn it over to Jim.
Good morning, Brian, and thank you very much. And good morning to all of you. Appreciate your time spent with us here today. We are talking about the Duct product today and the testing that has been done on it and how that relates to growing trends in the HVAC design and growing trends in code organizations. So in the last 10 years, more and more engineers, more and more architects are putting and looking to put supply duct, return duct, exhaust in the ground. And it's becoming a worldwide trend that we're seeing here at Minoxidant. So the very first thing that you want to think about as you present this to engineers and as engineers think about doing this themselves is, why is this push? Why are we here? Where is this going? And what's the advent of going underground in the first place? Well, the obvious answer to this question, and what you have seen before in previous webinars, is the whole displacement ventilation. Okay, uh, in up till say 12 years ago, the common way of doing ventilation was with mixed air ventilation, where in cooling mode, your air comes out at a very high velocity, at a very cold temperature, and both your supply and your return duct are at a high elevation. Well, displacement is completely different, where your supply duct is at a low elevation, your return duct is still up high, and in cooling mode, the air is coming out at a much higher temperature, at much lower velocity. The end result in a building, as you see in these comparison fluid dynamics shots you see here, the building on the left is representative of a mixed air ventilation, where the entire building is a homogeneous temperature and also a homogeneous mix of contaminants, whereas the building on the right, same building using displacement, has got that stratification of not only temperatures but contaminants being pushed up towards the ceiling. When you take a look at the EPA, their take on it is that, okay, yeah, we encourage this design change going from mixed air ventilation to displacement, not only for the energy savings, which are significant in cooling mode, but also because it is a passive way of cutting down on the transference of pathogens amongst humans. Anytime you have a large building where a whole bunch of humans congregate, any way you can cut down on diseases in that building is a bonus. So if you take a look at what ASHRAE did, they looked at hospitals using this technique. And again, this is been in other webinars. You can look back and read up on this if you like, but the basic concept is that displacement ventilation has become more and more popular, and it is likely to grow more and more, especially in large buildings. Some of the projects that Minoxidant has done through our rep system, the Dublin Performing Arts Center in California. This is a very large auditorium where every bit of supply duct was in the ground, return duct up high, classic displacement ventilation. The energy savings in a building like this or a room like this is absolutely tremendous, not to mention the fact that it's a quieter system. Another example would be the Davenport Public Library. Now this one, and again, this all goes back to why people are going underground. This particular project is the poster child for displacement ventilation, because this library system, they built two branches approximately 3-4 years apart. Same architect, so from space, these two buildings are identical. You have the same square footage, same layout, same elevations, obviously same geography. Two different engineers, however. The first engineering firm designed around mixed air ventilation. The second firm designed around displacement ventilation. Now they're looking at utility costs forensically in cooling mode. The building that's using displacement ventilation is using 60% less energy during the summer, 60. You can't ignore that. So obviously there's a benefit to going in displacement, and that's where this push is coming from. Our last example is the White Bay Cruise passenger ship terminal in Sydney, where every bit of supply duct was buried in the sandstone pier going out to where the boats, the ships come in. And again, this is another fine example of displacement ventilation, along with many others that we have done here at Minoxidant. So you get the idea that, of course, underduct can be used along with displacement ventilation, which then enables the architect to build even more open spaces and grandiose rooms. Okay, so you get the idea of why we are here. So now let's take a look at what has been required of non-metallic duct. Well, it's all about testing, okay? And that's kind of what we're looking at today as a whole. There's many different organizations that you can have your product tested for, and the one that Minoxidant has been tested with is through the ICC, International Code Council. Okay, so all 50 states and the District of Columbia adopt IMC, that being International Mechanical Code, as part of their state building code with some minor tweaks. Okay, so if you want to take your product and have it evaluated to make sure that it fully complies with your state building code or IMC, you go to what's called ICCES, Evaluation Service. And the evaluation service has a listing criteria that describes the testing that's required for whatever your product may be. And for non-metallic duct, that listing criteria is labeled LC 1014, and the four main tests that you see here is what is required: your surface burning test, your strength test, your leakage test, and your insulation test. Okay, so first and foremost, and this is geared exactly towards where other organizations are headed, is your ASTM E84 test. All right, this is an extremely important test, not only for health and safety, uh, but also for the design of the system. You're putting a duct into the ground, okay? So you want to make sure that this non-metallic duct has the capability to withstand fire and not collapse, and you end up losing your supply duct, your exhaust duct, your return. So it's a very important test, okay? So let's take a look at where folks are headed in the world of code and code bodies. Right now, SMACNA, if you haven't had a good weekend read, it's called the Thermoset FRP Construction Manual, which was originally written in the mid-1990s. Okay, I think it was 1995. And the original construction manual was geared mostly towards corrosion applications: wastewater treatment plants, odor duct, water treatment plants, chemical room exhaust, and it really had nothing to do with underground duct. Well, right now, Terry Cahill in our office, Minoxidant office, he's on the current task force that is rewriting the SMACNA Thermoset FRP construction manual. That's actually absolutely huge if you think about it. I believe this manual is slated to come out in 2016. And Terry informs us that SMACNA is now looking at a whole chapter of underground duct, FRP duct for underground use, whereas they kind of ignored it before. So in this rewritten thermoset FRP construction manual, one of the first things that they will be requiring, is a low smoke, low flame duct. So SMACNA understands the importance of that safety test. Underwriters laboratories. Right now, you cannot get a UL listed non-metallic duct for below ground applications. Their jurisdiction stops at the floor. That's easily checkable. You can call up UL and they will tell you that. However, we have been talking with UL ourselves because we find that they are now interested in going underground. They're looking to develop a standard for non-metallic duct. And the general consensus is that UL will be requiring a low smoke, low flame for non-metallic duct. And it makes sense because UL is all about health and safety. So what is this ASTM E84 test? Basically, it's a test where you have your material in a chamber that has a specified airflow, and you subject that material to a particular temperature flame. I think it's methane is the fuel of a certain size, and it has to be in contact with the sample for a minute. And after that, they compare not only the flame spread, but also the smoke spread as compared to red oak. Okay, and to pass this test, you have to have less than a flame spread of 25, less than a smoke spread of 50. Now, we have done our own in-house testing along with our third-party testing required by ICC, and I'm about to show you a quick video on that shows exactly what this test is involved with, and it shows you the results. So I encourage you to sit back, watch a brief video, and Brian, if you can, go ahead and start.
Hello, my name is Brian Phipps, and I am one of the engineers here at Minoxavent. Today, I invite you to review a video with me regarding flame and smoke ratings of ductwork. As we get started here, you will notice two separate videos with our underduct product on the left and a competitor's non-metallic duct on the right. Minoxavent tested these samples in the same chamber, using the same equipment, operated by the same individual. We are not an accredited testing laboratory, so these results are not official. This video merely demonstrates the importance of choosing a Class 1 duct material and provides a brief illustration of a Class 1 duct's capabilities. That being said, a third-party lab has tested our product, and Underduct is ICC listed for direct burial as a Class 1 duct material. According to the IMC, that is the International Mechanical Code, buried ductwork does not have to be Class 1, so our competitor is up to code in that respect. Whereas our competitor uses this line of code to say, why should my duct be Class 1 if it doesn't have to be? Our mentality at Minoxavent is, why shouldn't my duct be Class 1 if it can be? Once we remove the flame source, the competitor's product continues to support a flame, while underduct never ignited to begin with. Note as the duct on the right continues to burn, it melts and drips still burning product to the bottom of the test chamber. A disaster, such as the Centralia mine fire in Pennsylvania, demonstrates underground fires are not only possible, but a very real concern. The three primary ingredients to fires are heat, fuel, and oxygen. If a fire has access to all three ingredients, and suppressants such as halon do not interrupt its chemical reaction, combustion will continue. In conclusion, I hope this simple test illustrates the importance of choosing a Class 1 duct material. Thank you for your time, and have a great day.
Thank you, Brian. Clearly, what you saw there was an indicator of how well Underduct does um, stand up to fire situations. And as we go down the road where SMACNA is requiring this and UL is requiring this, and even if you take a look at obviously listing criteria 1014, they're requiring it for products that are other than what is currently specified. The bottom line is that we are way ahead of the curve on that, and more importantly, uh, the FRP duct itself, the underduct product itself, has passed that test. And before I go on to the pipe stiffness test, it's important to understand, because there are other FRP products out there that either have not passed this test, even done this test, or they have passed this test through the use of metallic liners. Okay, so let me explain. Envision that test that you just saw where we could take that underduct material, we could cut it in half, we could cut it diagonally, we can cut it longitudinally. It doesn't matter. That duct resin, that duct formulation is what has passed that test. So it will pass the ASTM E84 no matter how you slice it. Excuse the pun. Uh, if you take a look at other FRP manufacturers, they will pass that same test not through the formulation of their resin, but simply by putting in a metallic liner that blocks the spread on the interior only. So clearly, Underduct is way ahead of the curve in the ASTM E84 testing requirements just through its formulation. Okay, so moving on, the second thing that ICC ES demands through their listing criteria 1014 is the pipe stiffness test, okay? And for those of you who are not aware of what this test is, it's a parallel plate loading test. And what they do is they put a sample, and I believe the sample length is approximately 15 inches. And whatever the diameter of the duct is, they basically apply pressure with the top plate until that duct deflects 5% of its diameter. And then they look at the pressure that has built up in order to do that deflection. Building code states that underground non-metallic duct shall have a minimum pipe stiffness of 8 psi at 5% deflection. So for example, a 20-inch diameter duct, 5% deflection would be 1 inch. They're going to squish this duct 1 inch, and the pressure that develops behind that moving plate has to be a minimum of 8 psi. If you take a look at two of our samples that were tested by an independent lab, 6-inch and 20-inch, and your pipe stiffness 274, 230 on the single wall and double wall 6-inch, and then on the 20-inch 12.3 and 36.2. Clearly, we are way above what current building code requires. And understand that these values were achieved with duct that was based on the minimum standards of NBS, National Bureau of Standards, product standard 1569. So these are the bare minimum of our FRP construction parameters. As you've seen in other webinars, the FRP duct can be made much stronger, as strong as you like, including up to H20 loading capability without the duct being encased in concrete. So the bottom line is that our bare minimum standards, our duct has passed significantly through this test. Okay, so now the next test that ICC required from us was the leakage test. And this is important for underground duct for obvious reasons. In high water areas, you want to make sure that your duct does not leak. So what did they do? Well, whatever your depth that you're looking to be approved at is, you need to submerge your sealed sample, and the sample has to be a minimum of 4 fittings connected to 5 straight duct sections. Okay, you need to be submerged at twice that depth. Okay, so what you're looking at is a sample that was sent to a third-party lab, and it was held underwater, and a vacuum port was attached to the duct. And what this did was it applied negative pressure on the inside of the duct, which simulated the pressure that this duct would experience at 12 foot underwater, and it was left that way for 24 hours. And after that time, as you can see, the report states that there was no water infiltration. So per LC 1014, because we passed at 12 foot underwater, we are now approved to be buried 6 feet underwater. Very important in parts of the world that have high water. As a matter of fact, that Sydney, Australia project that you saw before, that is in a pierway, and every 12 hours that duct is underwater when high tide comes in. So obviously we are good to go on that and ahead of the curve as well.
Well, Jim,
Then
let
the
me
last,
interrupt you here quick to answer a quick question that's come in here. We've mentioned earlier that all of this testing is according to LC 1014 listing criteria for the ICC. Now, do all of our competitors and all underground ductworks have to pass all aspects of this listing criteria in order to get an ICC listing?
that's a good question, Brian, and the answer to that is no. And the reason for that is because of the way existing code. Remember, listing criteria 1014, uh, the test in it make sure that your duct complies fully with the way code is written. So if you take a look at what how existing mechanical code is worded, it states that underground non-metallic duct shall be PVC, HDPE, or approved. Okay, that's basically a slimmed down version of what it actually says. But the bottom line, you can use PVC, HDPE, or you can use an approved. Well, obviously we are not PVC or HDPE, so we had to get approved. Right now, again, if you want to use PVC and HDPE, those materials are not subject to all of the testing. And the biggest one is the low smoke, low flame. So the answer to your question is no, not everybody has to do all of the testing that we have. So then that brings you back to the statements before regarding SMACNA and UL, where looking down the road, this low smoke, low flame requirement is going to be becoming more and more popular. So even though right now existing building code states that you don't have to have this low smoke, low flame test, we at Minoxidant have always felt that has been number one priority, and obviously we have passed that test, so we meet future codes and existing codes as well. I hope that answers your question. Okay,
Yes, thank you, Jim.
so thanks, Brian. So the last test that listing criteria 1014 requires is an insulation test, and the test that was our underduct product was subjected to was the ASTM C518. Now, again, this has been the subject of previous webinars. I encourage you to go back and take a look at this. But what it entails, it's a heat flow meter, and you're looking at a picture of an example of what it is. You have something about the size of a microwave, and it has two flat plates, and you take your sample of whatever it may be, whether it be a piece of wallboard or a duct, and you use approximately a 1 inch thickness sample that's 12 inches by 12 inches, and that fits into this little microwave oven. The top plate comes down and the door is closed. And on the two plates, there are sensors in the middle, roughly about 4 inches by 4 inches on both the bottom and the top plate. Now, the bottom plate is kept hot, the top plate is kept cold. There's roughly a delta T of somewhere around 40 degrees, and they allow this to run like this for about an hour. So they monitor the power going into both plates, and they keep track of how much power is used to keep the hot plate hot and how much power is used to keep the cold plate cold. So what you're actually measuring is how much energy was being transmitted through that sample as the heat from the lower plate wanted to get to the cold plate on top. Heat always goes towards cold. So that being said, the underduct product was tested per this widely accepted test, which is what the Federal Trade Commission requires for insulation testing. And you can see the results here. Whereas our single wall product has a value of R1, the double wall product at 1 inch insulation was a documented R6 insulation value, which meets most, if not all, building code requirements throughout the United States. On just by increasing the thickness of that insulation, we can actually get up to an R14 insulation value. But understand that the product was tested properly with the ASTM C518 test, and it has passed the requirements of all building code. So that pretty much ends our discussion on what testing the Underduct product has been put through, how it is looking forward to requirements where especially the ASTM E84 low smoke, low flame requirements are headed. So understand that you have access to the leading edge product in this field according to standards. This is important to engineers. This is important to end users. What's important to installers is not so much what we've talked about today, but more so what it takes to install, what the labor is, how to estimate it, that sort of thing. So I encourage you to come back to our October webinar where we will be discussing exactly that. Interview with an installer who is now an estimator, who's personally installed this product and now regularly estimates projects with this in line. So you'll get to learn all about how much and what the details are on installing this product. I thank you for your time. I appreciate any comments that you might have, and you folks have a great day. Thank you.
Thanks, Jim. Before you go off on me here, I do have one more question that's come in here, a little bit last minute. You mentioned that the FTC Federal Trade Commission requires the ASTM C518 test for with regard to insulation values. But does the ICC require the ASTM C518 insulation test, or do they allow other methods for measuring insulation?
Oh, that's a great question, Brian, and it's actually a can of worms because there's a point of contention with LC, Listing Criteria 1014 through ICC, in that they do accept an alternative way to determine insulation value, although it's been discredited in the sense that this alternative method was put forth by an organization called NSF, okay, and it talks about the proper name is NSFP 374, and this protocol talks about thermal distribution efficiency, and whereas the ASTM C518 test physically measures how much energy you can get through a given product, the NSF protocol basically is a comparison test that, well, if we shoot hot air through a duct that's wrapped in insulation, and then we shoot hot air through your test duct, and well, the temperatures on the temperature difference between the beginning and the end are relatively close. Well, then this protocol states that this duct has the thermal distribution efficiency equal to that of a duct wrapped in R10. That point of contention is backed up by the fact that if you talk to NSF, they come right out and state that this protocol should not be used to determine R value, and it is not equivalent to the ASTM C518. Yet, right now, ICC-ES is allowing for that, which really doesn't make sense, but common sense tells you that if you have a laboratory, a third-party ICC accredited laboratory that tests not only our sample, okay, and comes up with an R6, and then tests a competitor's piece of duct that uses this NSF to justify insulation claims, and it comes out at R less than 1, I think it's a 0.92, and clearly something is wrong with that NSF protocol and should not be used. So that's just a common sense item that engineers need to look at objectively.
All right, thank you, Jim. And with the end of that question, that concludes today's webinar on fiberglass products. We appreciate the patience and time you've given us today in this ever busy and modern day. We know time is a very valuable asset, never seems to be enough of it, and we do appreciate the time you take to spend with us on these monthly webinars. This webinar, along with all of our previous webinars, can be found on our YouTube channel. So if you or someone else in the office or an engineer, architect, customer, you'd like to see one of our old webinars, you can go to our website at www.fiberglass-duct.com, click on the Dig Deeper tab, and click Webinars. If you have any questions that we weren't able to get to today, or something sparks your interest later on, feel free to give myself, Jim Wishusen, Sam Stelzner, really anyone in our office here at Minoxidant a call. We're more than happy to help out with not just the quoting process, but installation instructions, design questions, and so on. Next month's webinar will be on source capture products. It'll be on the last Friday of the month, which I believe is September 25th at 10 a.m. Central. And I thank you again. Hope to see you all there, and have a great weekend.